I'm Mr. Information, evil twin of misinformation. Let's talk about quadratics. What are they? Let's first take a look at linear equations. The most basic form of a linear equation is y equals x. When x is equal to some value, y is equal to the same value. When you add a constant, represented by the letter b, y will be equal to whatever x is plus whatever the constant is. The constant is also known as the y-intercept. By adding a coefficient to x, represented by m, y will be equal to the coefficient multiplied by x plus the constant. The coefficient is also known as the slope. Now that we have gone through a bit of review, let's actually work with quadratics. Quadratics are equations that have x squared in them. They have three forms: standard form, factored form, and vertex form. Let's examine its most basic form, y equals x squared. This is in its standard form. We can see that the graph is curved, which is much different compared to what linear equations are. This curve is called a parabola. Still, it follows the same principle of how y is equal to whatever x is, that being squared. If we look at the general form of this, we can see that a would be equal to 1 and b and c would be equal to 0. The easiest parts of the equation we can apply directly to the graph are a and c. If we alter a, we can make the curve narrower if a is above 1 or wider if it's below 1. If a is negative, the graph opens downward. C is the constant, or the y-intercept of the graph. Whatever value c will be the y value when x is equal to 0. The vertex is the highest or lowest point of a parabola. Vertex form is a form of the quadratic that gives information on where the vertex is located. To find the coordinates for the vertex, look at h and flip the sign in front of it. That's the x-coordinate. The y-coordinate is just whatever value k is, so the coordinates would just be hk. This is the factored form. It tells you where the x-intercepts are. Simply flip the sign in front of r and s, and those become your x-intercepts. Most questions about quadratics will ask you to solve for x. What does this really mean? Quadratics, no matter the type, will have three solutions. Think of it like three possible variations a parabola will touch the x-axis. The parabola will have two x-intercepts, one x-intercept, or zero intercepts. There are two ways to solve a quadratic equation: factoring or the quadratic formula. Factoring simply means you're finding the factors that multiply to the equation. You turn standard form equations into factored form, and from there you find the x-intercepts. Let's work through an example of factoring. Y is equal to x squared plus 3x plus 2. You want to find these two numbers that multiply to c and add to b. In this case, the c is 2, the b is 3. One way you can do this is to first write all the factors of 2.
There are only 2 for 2, 1 and 2. Those two numbers add to 3, which means they fit our criteria. The next step is to write it out. You should always write down the shells. Now write down whatever number worked. In this case, it was 1 and 2. So now what? Well, since the x-intercepts are when y equals 0, we can set this up to be x plus 1 and x plus 2. Now let's stop and consider, what conditions will make this equation equal 0? To answer that, one of the factors have to equal to 0. Let's take this factor and find out what x has to equal for this factor to equal 0. When we move the 1 to the other side, we get x equals negative 1. Let's look at the other factor. When we move 2 to the other side, we get x minus 2. So we have successfully solved for x. If you get an equation and the y value is not equal to 0, feel free to arrange the y value to the other side and continue as normal. There's also another method of factoring. Say you had 6x squared plus 11x plus 3. Because of the 6 in front of the x squared, you cannot factor normally. The method of solving this is called decomposition. First, multiply the coefficient of x squared with the constant. The numbers you need to find now are numbers that multiply to the new value you found and add up to the coefficient of x. 6 times 3 is 18. 18 has factors of 1 and 18, 2 and 9, 3 and 6. One of those pairs need to add up to 11. 2 and 9 add up to 11. Now we have to break the equation apart. This is just splitting 11x into 9x and 2x. Factor the two numbers on the left and right to the best of your ability. Now we do a factor of our term. These are our factors. When y is equal to 0, you can solve for x to find the x-intercepts. Last but not least, we can find the x-intercepts using the quadratic formula. The quadratic formula is minus b plus or minus the square root of b squared minus 4ac over 2a. Simply take the numbers from the standard form of the equation and plug them into where they belong in the formula. After solving it, we can get the x-intercepts. Let's use the previous example and solve the x-intercepts. The previous equation had 6 as a, 11 as b, and 3 as c. If we replace all the variables in the quadratic formula, we get negative 11 plus or minus the square root of 11 squared minus 4 times 6 times 3 over 2 times 6, which is equal to negative 11 plus or minus 7 over 12, which is equal to negative 3 over 2, or negative 1 over 3. If we compare our answers before, we can see that we got the same answer.
Okay, why should I care about quadratics, Mr. Information?
Quadratics on graphs can help model some simple things. For example, when modeling an object being tossed, its height will change over time. This graph is a displacement over time graph. It's common in physics, but you don't need to know physics to still use the graph. When you solve for x-intercepts when y equals 0, you get how long the object was in the air for. When y is equal to some other value, it means that the x-intercept you solve for is how long it takes to reach that height. The reason why you might get two time values appearing is because the objects at that height are at two different times. Another application of quadratics is optimizing a problem. Say for example you want to find the maximum area you can make with a certain amount of materials. Pretend you're playing Minecraft and you have 300 oak fences. We first need to set the variables for each side. To do this, we need to know what to set the values on each sides. Before setting up the actual quadratic, we first need to find out how much each side needs to be, but with a twist. You'll see soon. The corners will help with expanding the area, but aren't omitted entirely. Instead, they act as our constants, and now we have the sides. So let's set up the top and bottom fences to be x, and the side fences to be z. We now know that 300 fences will consist of at least 4 fences, and 2 x's and 2 z's. But there's a way to find out what z is equal to. If we solve for z, we get 148 minus x. We can now assign the value of the side fences to be 148 minus x. And now we just have to solve for the area. The area is just the side multiplied by the side. If we expand this, we get a quadratic. However, instead of solving for the x-intercept, we need to find the vertex. Why? Well, since the coefficient of x squared is negative, the parabola runs downward. That means there's a maximum value y can be. And since the y is the area, whatever x is equal at the parabola will give us the dimensions needed to find the maximum space for fences. To find x, use minus b over 2a. So x is equal to 74. So the length of the top and bottom fences will be 74 fences, and the side walls will be 148 minus 74, or 74 fences. So that covers 2 real-world applications where quadratics are used. I hope this will make learning quadratics less boring, and I hope you can find some sort of way to use it in your life. I hope that makes STEM interesting.